my name is Rich Casimiro, and I'm with the Foxboro M&I division. Have been for the past 22 years. I have a strong development background, and about 4.5 years ago I moved over to the other side, the marketing, business development side, and I'm really enjoying it. So first question I have is, this is a solution that is particularly targeted to upstream oil and gas. And I'm not sure how many of you folks are involved in upstream oil and gas. Is everyone familiar with multi-phase metering and upstream oil and gas? Or this, can I see any hands? A few hands? Okay, good. So most of you are. But I do have a few preliminary slides to just give you an overview of the opportunity and the challenges that are out there today in upstream oil and gas, and how we arrived at this net oil and gas solution. So if you bear with me for a moment, I'm going to give you just a quick background on the typical challenge and the type of traditional production metering equipment that's used nowadays. So I'm sure everybody has seen these types of things on the side of the road. These are pump jacks, which typically, pump oil out of the ground. And whether it's a pump jack or an ESP type of device, electronic submersible pump device, the operation in most oil fields is typically the same, that you have these multiple wells, and they go to what's typically called a battery, where you have a manifolded battery, if you will, where you've got all these different oil wells feeding into this battery here. And then that's typically where you use separators, traditional flow metering technology of separators, where you will separate the oil, the water, and the gas, and then be able to measure the flow rate of the important hydrocarbon, typically in this case oil, and in some cases gas. So again, to elaborate a little bit further, so now we're talking about separators. And there are two types of separators that are typically known in the oil field. And one is a production separator, and a production separator usually measures the oil, water, and gas flow rate of all the wells in a particular field, or a well pad. You may have 15, 20 wells, and they'll be all manifolded together. All these pipes will lead into a very large production separator. And the production separator has baffles, and you can see typically, unless it's very, very heavy oil, typically your medium to lightweight oils, the water density is higher than that of the oil, so the oil rises above the water, and then with the set of baffles, the oil will spill over the top, and then you have these drain pipes with valves and level devices and a bunch of mechanical claptrap, as we call it, to meter, whether it's a turbine meter or a PD meter or perhaps a Coriolis meter, to meter the water flow, the oil flow, and then the gas flow off the top of the separator. And also what is typically used in North America, not so much in other parts of the world, are, oh, excuse me, wrong button there, are test separators. And test separators is really just a smaller version of a very large production separator, where you typically use the test separator to monitor an individual well, one well's production over a 24-hour period. That's routinely done here in North America, and a lot of countries around the world are getting more and more interested in understanding what type of production is coming off of an individual well, even though perhaps a state-owned entity might own all the wells. Now they're trying to do reservoir management, reservoir optimization. So this is the type of equipment that's out there today. And I've heard numbers in the range of, for North America, of $300,000 to maybe as much as $500,000 to install a test separator on the pad at a well site, add all the tankage, the turbine meters, the level devices to know when to open the valve to flow, if you will, to storage tanks or piping. So that's the typical type of equipment that's used out there today, and lo and behold, what do we have? Now this is really exciting stuff. This is an innovative advanced application solution that we've put together here, and as you can see, excuse me, I keep using the wrong button here. As you can see, it's an integrated solution, and the neat thing that you can realize from this is that the flow comes into the piping and out the other side of the piping with a bunch of instrumentation, which I'll talk about. But no separation. There's no separation. This is as we say in the industry, the commingled flow regime of the oil, the water, and the gas at whatever ratios it happens to be flowing at the time. The continuous flow stream we're measuring on the fly, or my UK friend likes to say, in situ. We're measuring the oil, the water, and the gas content, the gas up to a particular level, which I'll cover, in situ. And it is really an integrated multi-phase meter solution, that measures the continuous streams for an individual well production, and it eliminates the need for test separators. So let's talk about a little bit more about some of the benefits. And this is really the sales slide for your sales folks to, get your customer on the hook on what's all the good things about it. In addition to being lower cost, capital expenses, and operational expenses, it really gives them real-time information to monitor the reservoir, whether it's a flood, a water flood type of reservoir to push the oil out of the ground, or a steam reservoir, or CO2 gas reservoir, whatever the lift mechanism is to push the oil out of the ground, out of the reservoir. The information is typically stale, if days or weeks old, that when it finally makes it to the folks that are managing the whole field, the whole reservoir. So this can give you real-time information, extend the life of the existing wells. What we're finding in many parts of the country, particularly in the world, especially in Russia, that they have grouped well production, but they're really not sure what's coming out of each individual well, and they want to start to look at individual well production and how that affects reservoir management, and perhaps maybe with the price of oil going up, some wells that are capped start flowing out of them and doing these types of well tests to see, is it worth, based on the price of oil, to run wells that maybe had lower production in the past. So you can read all those bullets, but that's the sales pitch and all the benefits here. So now we get into the meat and potatoes of what is it. So if you'll bear with me here, I'll just give you a quick overview. In this scenario here, this is the inlet side and this is the outlet side. So the flow comes in, and this is our obviously patented Coriolis flow tube, and this is our new CFD51 transmitter. As you can see, Coriolis flow meter. This is a water cut meter, and this is a third-party supplied water cut meter with this particular specialized version that is manufactured for Adventus for us. And this water cut meter is near infrared optical technology, and it has the ability to measure through in near infrared light spectrums, has the ability to measure the percentage of water in a water and hydrocarbon stream. And there's a calibration that you do when you set it up with a given oil and water, but it is a very, very reliable device. And then this is what we call the net oil computer. And we also use a temperature sensor as a reference for gas flow calculations. We need to know the actual temperature and line pressure. And you see a multivariable transmitter here as well, where we're measuring the DP across the flow tube, so we know the static line pressure and the differential pressure across the flow tube, as well as the temperature input from the temperature sensor that goes into the multivariable. So those are the piece parts. Those are the components that go into what we call the net oil and gas solution. And you can see that it's all self-contained in one integrated skid. The neat thing that Adventus is doing with these solutions is it is a fully Adventus-supported, delivered solution. We include startup, training, field service, and warranty support. We've built that model here in North America, and now I'm working with the Euro team for us to deploy that same business model, where it is a fully supported, Adventus-supported, integrated solution. Whereas I know one particular other manufacturer that sells a Coriolis meter, and they also have a net oil computer, but they rely on their reps and distributors to put it together and support it. But this is really supported by a major such as Adventus. This is kind of technical here for you techies. You can read through those slides to understand how it works. But basically, in a nutshell, the Coriolis flow meter measures the mixture density, that's the combined density of the oil, water, and gas stream, and measures the totalized mass flow rate of the liquid in the mixture gas flow stream. And then the water cut meter measures the percent of water in the total liquid stream, in this case water and oil. The multivariable transmitter measures the pressure and temperature for gas density reference. All of these measurements via Modbus communication to the net oil computer. And then in the net oil computer, we have these very advanced models that we've developed over the years with our Oxford team that has done tremendous amounts of research and development for us on our Coriolis meter over the years, working with Wade. And From that, we're able to measure the net oil, hence net oil, the net oil in the oil, water, and gas stream, flow rate, mass flow rate, and volumetric flow rate. And we're also able to measure now gas flow up to 50% GVF. And GVF is a gas volume fraction. I have a definition of that in the next slide or so. And this is really ideal for liquid and gassy liquid and water lift and moderate gas lift type of applications, or even applications where maybe partial separation is being done, where really it's a multi-phase application and the client is interested in measuring the gas flow rate at a condition of no higher than essentially 50% gas average in the flow regime. You may have heard the term wet gas, and this is not suitable for wet gas applications. Technically, a wet gas application is 95% gas volume fraction, minimum. So essentially what you're saying is 95% of the flow stream is gas, and 5% or less is liquid condensate made up of oil and water typically. So that's hence we call this the net oil and gas solution. I have two slides here, and really this is just kind of for reference for you. We have 5 Coriolis meter sizes from 1/2 inch to 3 inch, and really we're optimizing the net oil and gas solution around each flow tube side because in a nutshell, one model does not fit all Coriolis meters. The characteristics of the Coriolis meters and the flow regimes and the advanced models that are developed to be able to measure net oil and gas are not the same, unfortunately. So we have 5 different size meters, as you can see, and these are typical flow rates for each meter size of no gas, maximum liquid, minimum liquid, and then with 20% gas or 50% gas. And again, these are all in my data sheet that I've recently developed to help market and promote the solution. And as I said, gas volume fraction, we define it as the actual volume of gas as a percentage of the actual volume of flow of gas and liquid mixture flowing at any given moment. Okay, so from a sizing standpoint, it's hopefully these tables and the process parameters and the operating ranges that I've provided in the data sheet recently will help you to perhaps find particular applications that this might be suited for. But there are a lot of key questions that you need to ask for those of you who are working in upstream oil and gas. And these are a bunch of them. What type of measurements are they looking for? Are they looking for just the oil? Do they want to measure the water and gas? What type of lift is it? Water or gas lift, perhaps? Single or group wells, range of flow rates, range of line pressures, maximum pressures, range of water cut, range of GVF. What are the densities? Right now we can only handle up to a medium to just barely into the low medium weight range, up to a density of about 870 kilograms per meter cubed. So these are the types of questions that a TSC or your technical support folks would give you in vetting an application to see if it's worth, if it's suitable to what we have to offer at this time. And the important thing is, one, for those of you who aren't familiar, proper metering sizes is required because one size does not fit all, and flow rates can vary from well to well on a given pad, obviously. All right, so give you an idea of where we're at. I just got a few more slides here. So kind of highlighted in the red yellow here is the initial specs that we've actually measured in an independent lab, an independent multi-phase lab, which I'll get to on the next slide. And in green is highlighted in green are the specs that we're trying to achieve. So you can see right now that we know we have very good performance, and we're trying to improve. We're attempting to improve that. And my Oxford team is developing new models and running additional multi-phase test trials. And we're about to go back with our 2-inch meter to the multi-phase lab in the UK, upcoming in December. And we're hoping to be able, with improved models, to achieve these tighter specs. And for those of you who don't know, who may not be working in the Russian market, the tighter specs actually meet the GOS standard. The 5% error on gas flow, 6 or 15% on net oil, depending on the level of water cut, and 2.5% on total liquid. So from what we've seen, these are the tightest specs in the world right now for essentially custody transfer of oil and gas, and actually measuring the water as well. So these are very difficult specs where we're attempting to meet these specs. This is a requirement in Russia for 2012. It's actually mandated that they'll have to measure these constituents off of every well and to these accuracy specs. So in that regard, I'd like to explain and really boast, if you will, on the due diligence and the effort that Inventus is going to at this point, and the hundreds of thousands of dollars we're spending to validate the performance independently of the net oil and gas solution. So what you see here, this is a diagram. Keep pressing the wrong button, Rich. This is a diagram, and this shows a multi-phase test lab facility in the UK. We refer to it as NEL. It's NEL TUV test lab in Scotland, near Glasgow. And this is the setup that they have. They have it's essentially a separator, as you saw, where you've got a commingled. You have a commingled string of oil, water, and gas. They separate the water out, the oil out, and we do gas injection at various levels, and we commingle the three streams. And then this is our skid, in schematic diagram. We would actually be standing upright. And what we're able to do is we have reference meters, single-phase reference meters. We happen to know of a really good Coriolis meter, so we're using our own Coriolis meter with validated calibrations as reference meters. And that's it. We have a very extensive test matrix that we've been running at this NEL lab for months now. And we're looking at various levels of water cut. We're looking at various levels of gas void fraction in our ability to accurately measure net oil and gas. And I can tell you that those gas specs are the most stringent standards in the world, and we're right now very, very close to meeting them, and we hope that we'll be able to prove to ourselves and validate the performance with an independent published report that we can meet those specs. And as soon as we're able to do that, my colleagues like Andrei Lepikin and Boris Muratov's team, they're going to be selling these things like hotcakes because it is, as we said, it is a requirement in Russia. And in terms of a field trial, I had hoped to have some results to report by this conference, but we're just not quite there yet. So our very close customer in Russia is, is preparing a field trial. This is actually a heated enclosure that they use in Russia because obviously it gets very cold, very, very cold in the wintertime. And this is where the equipment is installed. So right now they're looking at fitting the net oil skid, or I should say shoehorning it into this enclosure. But this is it, and they're going to be running a trial right now in the November-December timeframe. They're hoping to finish up by the end of December. And inside this enclosure is a competitor Coriolis meter that has the luxury of separation, where everything's all separated out, and the gas is being measured separately, and the oil is being measured separately. So we're going to do an in situ field trial to prove to the customer and ourselves that it's as good as we say it is. And this happens to be a handsome gentleman here, Alexander Lishuk, who was formerly with our customer, is now working on a consulting basis with us, helping us to make inroads. And that's our colleague there. So we're really hopeful that we're going to get great results and have validated independent multi-phase lab performance. And all I can say is that I've looked at the competitor data sheets, and I don't see anybody that's looking to meet and specify measurement accuracy performance on the three phases like we show on the specs that we're shooting for. So it's pretty exciting stuff. We wish we could do it more quickly, but unfortunately, contracting and buying time at these multi-phase labs is very expensive and time-consuming, and we don't have endless resources, unfortunately. So it's taking us some time, but we hope that this coming fiscal year is going to be really great for us, because we hope to have an offering of the net oil and gas skid solution in the 1/2 inch, the 1 inch, and the 2 inch meter that will have gone through independent multi-phase lab testing, when we know we have an independent report with validated performance. So I think I went through that just about on time. It's 4:15. 10 minutes? Okay, I'll sing. No. Oh, well, that's because we started late. As we started late, I was trying to get us back on track. Yeah. Plus, I'm from New England and I talk fast, so.
Rich, you did great. Thank you very much.
Thank you so much.